Yeah, thank you for coming out to this talk. And within the next 50 minutes, I would like to talk about our journey transforming our monoliths into microservices, but from a startup perspective. So we have heard before, Zalando, a large organization. We are not that large. We are very, very small still. But we decided to transform our monolith into microservices, and I would like to explain you why. And another aspect is that we have to deal with the balancing act because we are providing our solution, I come to this one later, in the cloud environment, but also on premises. So our customers are also installing our product onto their local machines, onto the local service. So beginning of this year, we had a team meeting reviewing 2015. And we were talking about problems and successes. And one of the problems that we were talking about was that we missed a milestone, a very critical milestone. And when I asked my team, so what was the problem? They said, well, we missed the milestone because we introduced microservices. This was slowing down our development pace. So to explain why we are still pursuing the microservices path, I would like to go with you back to our beginning. So a couple of years ago, we founded our startup Just Software. We built a B2B solution for simplifying your communication and collaboration at work. And everything was a monolith in every aspect. So one small team was working on one collaboration product, and it was based on one technology stack, and everything was monolithic. So after a while, everything evolved. So our team got bigger, and our number of users increased, and we were adding more and more functionality to our product itself. So it's supposed to be fantastic, but instead it was feeling like clumsy and slow, because our team complained that everything takes too long. So it takes too long for meetings, for decisions, also for discussing about problems, even though we are still small, but we were growing after a while. And one other problem was that we don't have really well-defined responsibilities. So there was no real code ownership that we had. And for example, when a bug arose, this took a while until someone felt responsible to fix it. And in terms of our product, we were adding more and more functionalities, more and more features, and our usability and user experience suffered over the time. And regarding our software architecture, it was a little bit more difficult to add new features without impacting the entire system. So after a while, there evolved this very urgent need to change things. And there evolved the desire to split up things. And this was at first product and also cultural or organizational driven. So regarding our product, our collaboration product, we were focusing on usability and user experience improvements. And so we divided our one monolith product into single apps so that each one of them takes care of a specific problem, and that one very well. So we divided our Just Social into 5 different apps. So it's Just Connect for connecting and sharing information with your colleagues, Just Drive to exchange documents, Just Task to take care of your personal and also your team task list, Just Calendar to manage your appointments and also your deadlines. And the Just Chat app to exchange messages in real time and collaborate in real time. So the other shift that followed was that we divided our one big team into smaller teams to achieve in the long run, to establish small, autonomous, agile teams. And to each of these teams, we assigned the specific apps to achieve well-defined responsibilities. So we changed not only our product, but also our organizational structure. And from the previous talk, you might have already heard about Conway's law. Well, in the 60s, the programmer Melvin Conway stated that your organizational structure has a very huge impact on the system that you provide. And Michael Nygaard also mentioned in his book Release It that the team assignments represent the first draft of the architecture. So after we have split it, now our product in smaller chunks and our one big team into smaller teams, it's a kind of like reasonable logical step that we look now at our software architecture. So we started with a monolith, and as a lot of other enterprise applications are built in, and the problem is that the change cycles were very tight together. So when you want to change a small part of it, you have to rebuild and redeploy everything. Then in a monolith, it's very hard to keep your modular structure, especially when your team grows, because behavior is spreading around across modular boundaries. And if you want to scale, you have to scale the entire monolith. And the problem also is that we needed to stick to the technology that we first decided to build our software on, and it was pretty hard to apply a different technology stack. So in the long run, we wanted to split our monoliths into small, autonomous, decoupled microservices to gain flexibility. And the flexibility that we wanted to gain is that we would apply different technology stacks independently. So with decoupled microservices, it's very easy to apply different technology stacks and without affecting the others. So you don't have to follow the one-fits-all strategy that we had in a monolith. Instead, you could pick the technology stack that fits best your purpose. So in our case, our monolith was based on a Postgres database, and we wanted to also apply different database servers as well. For example, in our chat app, we wanted to introduce a NoSQL database. So this is now possible, introducing microservices. So, and also, we want to adopt new technology more quickly, because since the risk to introduce this in a microservices world is much lower than in a monolith. The next one is ease of deployment. So in a monolith, when you change a single line of code, you have to rebuild and redeploy it all. So the problem that we were facing is that the risk for deployment was higher, so your deployment cycles are very, very long, and you're deploying less frequently. Your changes within the deployment cycles are piling up, so that you increase your risk for deployment. And with microservices, instead, you can deploy a single service independently and deploy faster, and also release earlier and get earlier feedback from your customer. And this is also very important for us as a startup, because we can then we can get feedback from our customers and validate our product and iterate and probably also pivot. The other part is, but this is not very important for us right now, but I still mention it, because we're still on a small scale. But in the future, it's easier to scale some services individually, while in a monolith, you have to scale everything together. And so we can, in the microservices world, we can scale those services that require more resources and leave other microservices run on smaller, less powerful hardware, which is very useful when you run it on demand provisioning systems. We are not still in the phase, so like Zalando previously mentioned, they are running on AWS, so we are not in this stage yet. The other one is that with decoupled microservices, your failure is not cascading. So when one service goes down, the others are still up and running. For example, when our document app, our Drive app is not available anymore, we still can use our chat app. So and this is also very important for us from a startup perspective, because we can add new features more easily, because we are now dealing with smaller parts, and we can, in combination with the easy deployment, we can release them earlier. And we get early feedback, as I mentioned before, from our customers following the lean startup principles. So we gain a lot of flexibilities in different aspects, but it comes with a cost. And so our microservices are not communicating over the network anymore in one process anymore about function calls, but instead over the network. And network is slow, as you know, so they're much slower than in-process function calls. So our performance suffers somehow. And also, the network is not reliable. That means that every remote call can fail at any time, and it adds complexity to your structure, to your system, because you have to design it for failure. And in a distributed system, you're losing consistency, and that means while in a monolith you can handle every operation in one transaction, this is not possible in microservices anymore, because you're updating several resources. And if you have to keep your consistency, then don't split it at that time. And for sure, it adds more complexity, operational complexity, because you have to deal now with more parts. So your complexity for deployment and monitoring is increasing. And it's also very tricky to debug across service boundaries, because you have to figure out how to consolidate different log outputs on different servers. So handling these complexities require more skills and more tools, but also a cultural shift towards a DevOps culture. So now, after we know the benefits and all the drawbacks and measuring the trade-offs, the question arises, how the heck do we start now? And before we start how we did it, let's go back to a few key concepts, because that's something that we have to keep in mind all the time. And your mindset has to change somehow. And one of the key concepts of modeling good services is the loose coupling between the services and the high cohesion within a service. That means when services are loosely coupled, then you can do a change independently and deploy it independently. And high cohesion within a service means that related behavior shall sit together in one service. So if you want to change the behavior, you would like to change it at one place. And if you have to apply a change on several services, you have to redeploy all these related services at once, which then leads to high-risk deployments again. I need to drink. Sorry. In context of loose coupling and code reuse, that was something that we had a little slight problem with, because or don't repeat yourself principle. Because as a software engineer, when you see duplicated code somewhere, the first reflex that you have is to optimize and abstract it for code reuse. And don't repeat yourself leads you to create code that can be reused. That's fine within one service, but it's not good for across service boundaries. Because if you implement shared libraries, for example, then this will result in too much coupling. And too much coupling, as we have heard before, eliminates the benefit of microservices. So, in fact, it's worse to introduce too much coupling instead of code duplication. So we have to give up this principle and introduce duplicated code. And one of the other key concepts we have to keep in mind, not only modeling good microservices, but how to model the communication between the services over the API. Well, it has to be stable, and so avoid breaking changes. Otherwise, your consumers have always adapt to your changes and provide a version as well, so that different versions can coexist, that your consumer doesn't have to adapt your change. And also follow Postle's law to achieve robustness. So it's relevant to create a robust system in terms of that your own service should use the most recent version of another API, but yourself as a service should provide an API that allows your customers to request also older versions of your API. And also keep it technology agnostic. So if you dictate as a provider of your API your consumers to implement in a specific technology stack, then your consumer is losing the flexibility of selecting its own technology. And while the other one is self-explanatory, simple to use API is very relevant. So, and also another communication styles that has to be reflected is how do we handle the communication, synchronous or asynchronous. For example, about it was a published event subscribed communication, and I come to this later, how we implement it in our world. Well, and the one that really was adding complexity to our architecture is that we have to design it for failure to be resilient. And so we have to put on every remote call a timeout. And you can also consider, instead of displaying an error message when one service is going down, to provide default values, and also introducing bulkheads in terms of, for example, that one microservice has its own connection pool and not sharing it with others, to avoid that an exhausted connection pool will then tear down all the other microservices it relates on. And the other one, circuit breakers, but that's not what we have implemented yet. But it's something that when you have a failed microservice, it does not forward subsequent requests to this failed one. Instead, it returns right away an answer with an appropriate error message, for example. So now let's split the monolith. Finally, after we have now talked about the key concept and about how to model good microservices and how to manage or how to handle what key concepts are related to the API and the resilient system, let's now start splitting our monoliths itself. So one service should do one thing very well. And things that change together shall also stay together. So you need to identify first the bounded context to put in the seam to extract microservices out of it. And one approach could be, for example, ours is a Java-based application, and so you can go first, for example, identifying your package structure and try to find the seams there. We use a different approach. I come to this later, and so you also go from a higher level microservice to finer grade. So don't start with a microservice. Instead, use the high level bounded context first and use this as a starting point to divide them in smaller parts. And also start slow and do one service at a time and learn while you go. That's very important. So the bounded context that we use on a very high level is our apps, each of them. And we but one of them was the Drive microservices exchanging the documents. So this is one of the microservices that we use. And you can split your monoliths with different approaches. For example, you can also say, well, let's first split our database, that you first split on the database level, and then after you're confident with the themes, then you can follow with splitting the services, because then you're adding complexity since they need to communicate over the network. And we followed a different approach, because the new Drive app is not an exact equivalent of the old one. So we added more features, and we added a new design, a new user interface, and also the data structure is more complex than the older one. So what we did instead is we built a microservice from scratch and let it coexist to the current one, and then migrating the data after a while. So regarding the communication, is that, for example, that your chat app, you can exchange messages in real time on the one hand, but you can also upload documents. And so the apps are the apps are integrated with each other. So, and when you upload a document to the Drive microservice, it's handled in a synchronous REST call. Because on the chat itself, we would like to have direct feedback on the user interface if the operation completed or failed. So, and while we are uploading the document on the Drive microservices, who has the data authority of the document itself, we want on the Drive microservices side also display author information, who has created this document. But the profile data is not residing in microservices. The data authority of profile information is still residing in the monoliths on Just Connect app. So what we do now is that we duplicate data. So the author information is then a part of the profile information that is saved in the data store of the microservice. So whenever we display a document, with its author information, we don't have to request all the time the data from the monoliths. But what we have to make sure is that we keep the data, the duplicated data, in sync. So we then establish asynchronous event-based mechanism that once the profile data on the monolith has been changed, it publishes a change event, and the Drive microservices who has subscribed to this event then takes the action to update its profile data on the document store. And the chat app itself also duplicates data. So after having uploaded the document, it takes duplicated data of the document, but only a small extract of it. So the continuous delivery pipeline is the same like in the monolith, except that you have to provide a continuous delivery pipeline per microservice. And you can do it by, for example, establish your own Git repo per microservice. We did it a little different. We have one Git repo, but different Git projects. And each of them is then representing a microservice. And what's relevant for the testing phase is that the testing pyramid for monoliths and microservices look quite alike, except for the fact that we introduced consumer-driven contract tests. And due to the fact that we now have to handle different APIs, we have to make sure that we are not breaking them. And consumer-driven contract test supports you with that, for example, using the open source tool Pact. And the consumer-driven contracts test, they are based on a negotiation between consumer and provider, and they are defined in consumer contracts. So you use these consumer contracts in two different ways. When testing the consumer, it generates a provider stub, returning the responses the consumer expects from the provider. So, and on the other side, the consumer contracts, when testing the provider, generates the requests, and then tests the responses of the provider API against it. So you can make sure that whenever you do a change somewhere, and some tests failed, that you have to either communicate with each other or have to fix it on your side. So when both of the tests succeeded, then you can publish it to production. And now let's come to the cloud and premises environments. So as I mentioned before, we have the challenge that we provide our solution on the cloud environment, also on premises. And right now we are handling it. It might change probably later on, so while we gain more experiences. But for both sides, for both environments, we are providing the same artifact. And these are Debian packages. Or sometimes we also have Red Hat RPM packages as well. But let's concentrate on the Debian packages first. So we have Jenkins' job, building the artifact, the Debian package, and upload it to our Debian mirror onto the dev stage. And we have other Jenkins' job taking care of the deployment on the specific environment. So that we run, for example, when we run a deployment on the test server, it points to the Debian mirror and do an apt-get install or apt-get update. So, and when it then goes from stage to stage, we move the Debian packages with repre-pro from one stage to the other on the Debian mirror. And we are dividing stagings mirrors on our mirror itself because we are following different cycles. So when we do a deployment on cloud, it happens much more frequently than we provide our Debian packages. So that's how we manage to apply different deployment cycles. And so the deployment cycles for the Debian packages are manually triggered. There's no automatic process. So when you shift it from one stage to the other, the only automatic process that it's on premises is the execution on the development of the testing side. And what we do now when we install it, well, the thing is that you want to have on premises solution that you don't want to duplicate your infrastructure. So that's the approach that we follow now, and that we have the Debian packages that we can also use for our cloud deployment. And so we are running in a post-install cycle during the installation, Ansible in the background. And Ansible we have already introduced from the very beginning. And so the Debian package itself is just executing Ansible playbook itself. And then it detects automatically on your server, for example, whether a database server has been already installed, because you have installed other microservices that depends on the same infrastructure. So we are merging some of the microservices in database layer and also on the application server itself. And with this, we are achieving it that microservices are losing their own process. But we know that for us it's more important that we are not duplicating the infrastructure on a premises solution. That's the reason why we are following this approach anyhow, even though that we are then violating one of the microservices policies. As a summary, so especially from a startup perspective, start with a monolith first. Especially if you're in the minimum viable product phase and you don't know if your product will hit the market nerves, it does not make sense to introduce microservices from scratch, because it takes too much time to keep up with the complexity, and you don't have the staff, the resources on the other side to handle it. So, and there's a good example about Eric Ries, the author of Lean Startup. He's mentioned that they used 6 months to establish a very beautiful software architecture. It's not only related to microservice itself, but they were building a very nice product with a beautiful software architecture. And after 6 months, they noticed that no one downloaded it. So, and he said, well, they could have spent 6 months at the beach, and they would have learned more than instead of like building a beautiful software architecture. So that's the reason you need to have, especially in the beginning, fast feedback from your customers, because probably you have to pivot. And also, it's very relevant that you start slow with one service at a time, and that you learn while you're going, and define high-level grained microservices, and then split it from that point into finer-grained ones. And it's also important because you're now dealing with more parts that you get your build and delivery pipeline ready. And since we are now working on an unreliable network, we have to design it for failure. And in general, it's not only a technical, but also a cultural shift towards a DevOps culture. Do you have any questions?
Any questions?
Hi, thanks for the talk. So at the beginning of your talk, you mentioned that or at least your developers think that you're moving slower because of microservices. So are you?
I'm sorry?
Well, are you moving slower because of
yes.
microservices?
Yes, we were moving slower because we had to add more. We have to take care of operational complexity and also design it for failure. So at the very beginning, if you introduce it, you are much slower. But this will increase, hopefully, after we have introduced more microservices.
I'll just start next. So you were talking about the cultural shift?
Yes.
That's always a bit of a challenge. So what was the biggest challenge for you, or is currently the biggest challenge for you with the cultural shift?
With the cultural shift? The thing is that our teams, it was the desire to split the teams itself. It came from the teams themselves. They wanted to split themselves into smaller teams. So, and the thing is that you're now dealing with one responsibility. Usually at the very beginning, everyone was taking care of everything, and the knowledge was spread across all the teams. That was great. You can point a question to everyone. And so that was kind of like difficult because now I don't know anymore what happens in the other team. And in our startup, we have a very strong opinion about everything. So and it was kind of like, it's kind of like difficult to tell them, well, that's the autonomy of the other team, so you have to trust them. So that kind of like was a kind of challenge we had.
Hi. Yeah, thanks for your talk. I had a sort of similar question regarding the culture.
Mm-hmm.
So you talked a lot about IT and IT teams. How was this change perceived by the non-IT people in your company?
Yeah, for them, because we also shifted their, for example, support, we shifted also some splits in there as well. So they were dealing with it much better than before because now they know who's responsible for what. And in the other situation, they didn't know who to address a specific problem to which people. So for them it was more clear after we have introduced it.
I just wondered if you started this journey again today, so you're starting again from scratch on this journey towards microservices, what would you do differently?
Good question. I guess I guess we wouldn't do it differently now. Because so if we have a microservices, a monolith architecture, and we don't add new features to it. So we did two steps in one. Probably I would not do 2 steps in one, because this really slows down everything. So I would then go not from scratch, but using the existing one.
I have one question. So it's me.
Sorry.
So you told that you divided the system into the small components, but how did you do how did you implement the shared components, like for example, security, monitoring, logging, and so on? How you manage it?
So yeah, that's a good point, because we have not solved it yet. So currently we are running behind a firewall, so these are not public APIs yet. And we have to dealing with API credentials, but that's something that we're still suffering. Like, shall we use this authentication and authorization handling that we do right now? So we're still in the middle of it. So we're still not, or would rather say we are still at the beginning of splitting our monolith. And one of the key things that we have to deal with is the security itself.
And the question, how is segregating the data of clients?
I'm sorry?
How is segregating the data of clients? So how are you segregating the data of clients? Because I think it's requirements that you have to segregate data for different companies or different clients.
You mean in terms of like...
personal data,
yeah.
Protecting personal data and so on.
So we have not figured out this one yet. So especially when the client is authenticating it, there's one entry point taking care of kind of single point of failure, to be honest, and that is taking care of the authorization and authentication, and then these visibility. So we have some security aspects, limits, for example, that not everyone can see a specific document on the drive. And what we do is we duplicate the visibilities and the right management, the data for it, to request it then separately.
We are also splitting up our monoliths and now have a really large number of microservices. I'm a DevOps guy, and I sometimes need to slow down the teams to have new virtual machines, IPs, front-end facing names, because we also have to have a SSL certificate for it. Do you also have sometimes the need to slow down the teams to make even another remember my password service or something?
We're still very small, but I can sense what you feel, how you feel. But yeah, since we are still building also on our infrastructure, I guess sometimes I have the feeling, okay, shall we don't split it continuously instead of stay at this point right now and then to stabilize it. Sometimes it's the pace. It's faster that the infrastructure get complex very soon. So yeah, it's a trouble that we have as well.
I have a question. I think I missed this part in your talk. How big is your team actually?
We have now we have small. We are 11 in total, and we have 3 teams. And so we have 4 and 5 teams and a 2 team that is then responsible sometimes for building the delivery pipeline and then pushing it to the teams.
Hi, I was wondering how many microservices do you have in total, and how do you map a new microservice to your old monolithic structure? Do you have just one microservice per, I think you called it app, or do you subdivide your apps to multiple microservices?
And now currently we are still at the higher grained level. So and then we decide whether we would like to finer grain them subsequently. For example, our Drive app is still one monolith. The next step is, for example, we have a document preview, we have a document search, and we have document versioning, document commenting. So we are trying then to figure out, is it now the ideal situation to split those larger microservices? But we're still in this process.
Any more questions?
With small teams and each one responsible for its own microservice, how do you handle knowledge transfer, or if someone gets sick or goes on vacation? I guess it's much more difficult in a startup than in a larger organization with large teams.
Yeah, so your teams have to have a specific size, because otherwise our teams are 4 persons, for example, and 4 to 5 persons, and so if one gets sick, then you still have the knowledge in that team. So, but it has to have, and that's also the case if you. A startup with only 2 of you, then don't introduce microservices, because you can't really deal with it in the very beginning if you're still very small.
Thank you. Also got another question, because I think with the product you need to maintain a consistent UI, and if you have a microservice for each app, how do you manage a consistent UI? Do they share the same library or something?
No, they're not sharing libraries, but CSS files. So, and we also have a style guide, and this is applicable for every app. So, and to achieve, we are not there yet that we are full autonomous teams with cross-functional teams, because then we would have assigned to each development team also a designer and also a DevOps responsible person. But instead, what we have right now, because lack of resources, is that we have our teams and also a designer taking care of it. But in the long run, we would like to establish designer per team. And then they communicate, like how you establish then one look over the product themselves. So we right now are negotiating with a style guide.
Thanks.
Hi, I'm here. Thank you for the presentation. My question is about the communication styles between microservices. You talked about sometimes duplicating data, relevant information at microservice is better choice because you need the other one to be there all the time in order to synchronously communicate. So is there a rule of thumb you agreed upon when to make the communication asynchronous with events, or when to go on with regular synchronous communication that could be REST calls or whatever? So this is a very confusing part, especially at our team, because we sometimes get confused whether to take this data from somewhere else, because it is the main authority of the entity and the information is basically there. But we get confused because sometimes we want our microservice to be autonomous, to continue operating without the monolith. For instance, in your case, the drive must continue working even the monolith is down, maybe, because you want it to be autonomous. So we get confused. Did you decide upon some rules that when to make the communication asynchronous or go on with the synchronous communication?
We are kind of confused as well. So we have to. Sorry. So what we decided from case to case. So if we only have one communication partner, for example, when the chat app is uploading a document to the Drive app, so it's a one-on-one communication, then we tend to, and also if it's necessary that the user itself needs direct feedback about the operation, if it's completed successfully or failed, then we tend to use the synchronous communication style over REST. But if we, for example, in the duplicate data, if it's kind of like keeping your duplicate data in sync, then usually you have more communication partners involved, because it's not only you that needs to update the data, but also other, for example, the search index or something like this. So then we prefer the decoupled way to request it then when the event has occurred, published.
So sometimes you look case by case, and sometimes you prefer temporal coupling because you lose the authority. So you rely on fault tolerance. You lose some of fault tolerance, but you build for failure then.
Yes.
That's the...
yeah, exactly. So yeah.
Okay.
So when, for example, if the drive app is not available, and then it says it's publishing or it's displaying an error message.
Okay. Thank you.
But we can live with that. Yeah.
All right. Thanks a lot, Susanne.
Thank you.